The JuiceFS Community Edition will introduce Python SDK support in version 1.3.0, allowing you to bypass views and directly read and write files in JuiceFS programmatically. This is particularly friendly for strictly permissioned, virtualized and containerized environments, and can effectively meet the needs of AI training, inference, and other scenarios that require large-scale data loading and sharing. Although it hasn't been officially released yet, you can already access the Python SDK code in the main branch of the JuiceFS Community Edition repository. In this video, let's get a sneak peek and learn about its compilation, installation, and basic usage. To make the demonstration as close to real-world usage as possible, I'll be presenting and explaining in Jupyter. Right now, you can follow the instructions on the screen to visit the project homepage and download the accompanying Jupyter notebook for free. Once you've downloaded the Jupyter notebook I've prepared for you, simply drag it into your local Jupyter instance. First, let me introduce the environment I'm currently using. To better simulate a real-world application environment, I'm working inside a virtual machine. I've set up a new Ubuntu 24.04 environment. The first step is to resolve dependencies. When compiling the JuiceFS Python SDK, we need to use Go, Make, GCC, and Python, as well as some related Python packages. So here I've provided a command. Once you copy this command, open a new tab, select this terminal, and paste the command to run it inside. This way, we've prepared the environment needed to compile Python SDK. Once the environment dependencies are resolved, we can officially move on to compiling the Python SDK. The first step is to clone the JuiceFS open source repository. Here, I've already prepared the relevant code. This code block contains two commands.
Clone source code.
The other command is for users who have already cloned the repository. It will pull the latest code changes from the repository. Select this line of code and click the Execute button above. Once the code has finished executing, we can expand the file manager on the left. You'll see that the JuiceFS code directory has already appeared in our file manager. Now we can proceed with the next steps. Now that we have the source code, we can proceed to compile it. First, let's compile the libjavs, so shared library. This is the core dependency of the JuiceFS Python SDK. It implements the underlying logic for interacting with the JuiceFS file system, such as reading and writing files. Creating directories, managing metadata, and other specific functions all require calling this library to perform the actual operations. Now, let's select this line of code and click to execute it. The system will download all the required Go modules as dependencies. After the compilation is complete, expand the file manager on the left and navigate through the directories one by one. Here, you can see the header files, but you won't see .so files because Jupyter hides shared library files. If you want to see it, you can switch to the terminal. Here, we can see this file. This file, libjfso, is about 150 megabytes after compilation. All right, let's go back to the notebook. Next, we'll start compiling the Python SDK. Select this line of code and click to execute. Once the compilation is finished, we'll get a .will file. Expand the file manager on the left, go back up a level, and find the dist directory in this folder. You can see that the Python package we compiled is right here in this directory. All right, let's move on to the next step, installing the Python SDK. I've already set up the relevant parts. All we need to do is select and run the code, and it will copy our compiled Python package into the root directory of our Jupyter project. Switch back to the Jupyter root directory, and you can see that the package has already been copied over. All right, next, let's select the second line of code and run the installation. With this, the JuiceFS Python SDK has been successfully installed in our current working environment. Before we get started, there's something to note. The Community Edition of JuiceFS and its Python SDK currently do not support formatting a new file system. Therefore, before using it, you should manually create a file system first, and then use it together with the Python SDK. If you still don't know how to create a file system, you can revisit our first video, where I provided a detailed introduction to the entire process of building a JuiceFS system entirely using cloud computing resources. Additionally, when using it, you can flexibly use the help command to get help information from within the SDK. You can use dir command to list classes and methods of the SDK. When using it, the first thing we need to do is initialize the client. Let's look at the first piece of code. Here, I imported the client class. Then, I subsequently use a pre-created file system to initialize a client named JFS. This particular client is modeled after Python's comprehensive OS module. So if you're already familiar with operations in the OS module, you'll find this client easy to use as well. Once the client is initialized, we can use its built-in methods to work with the contents of the file system to perform management operations like creating, deleting, updating, querying files. Let's move to the second piece of code. This lists the root directory's contents. After selecting the code and clicking Run, it lists files and directories already in our file system. Store items. Alright, the next piece of code is for creating a folder. Let's select the code and click Run. Then go back to the command for listing contents and run it again. You can see that the folder we just created has now appeared in the list. Next, let's try creating a new file and writing some text into it. Please select this line of code and then run it. After writing, let's return to the command for listing directory contents and run it again. You can see that the newly created file has appeared. Now, let's try reading the contents of this file. Select the code and run it. Okay, in this way, we've read the contents of the file. It's easy to see that these two lines of code are almost exactly the same as how Python's OS module reads and writes files. Alright, next, let's try deleting the file. Select this line of code and click to run it. Good. Now go back and run the command to list the directory contents. You can see that the file we just created has already been deleted. In addition, JuiceFS also provides a file interface implementation based on FSPack. FSPack is a Python library that provides a unified abstract interface for both local and cloud file systems. By implementing such an interface, you don't need to worry about the underlying storage details. Users can operate files and directories in a standardized way. At the same time, it can be seamlessly integrated into tools and frameworks that support FSPack, such as Pandas and Dask. This feature is especially convenient for use in machine learning and data science scenarios, making it easy to efficiently store and access large-scale datasets. Accelerate the model training and the inference process. When you need to access the JuiceFS file system via FSPack, you need to import both FSPack and the relevant protocol implementation for JuiceFS. Similarly, you also need to initialize a client. However, at this point, you need to use the built-in file system class in FSPack to initialize the client. The first parameter is the protocol prefix for JuiceFS. Here, you can use either JFS or JuiceFS. The second parameter is the name of the file system, which can be left blank, because the file system name is already recorded in the metadata engine of our file system. Of course, you can also specify the file system name if you wish. The third parameter is the address of the metadata engine. The fourth option enables automatic directory creation. After running this code, client initialization is complete. You can see following series of management commands are very similar to what we do in Linux terminal. We use lse to list files in root directory. Create directory. Next is the copy command, copy files from local directory to the root directory of JuiceFS. If we check again, we can see that the files have been successfully copied to the file system. This command is used to check whether a file exists. So here, you can also use the standard open method to read and write files. Finally, we can use the rm command to delete this file. That's all for this video. If you have any questions or other topics you'd like to learn about, feel free to leave a comment below. I'll continue to update content based on your feedback. You're welcome to join the JuiceFS WeChat group or Slack channel to connect with more JuiceFS enthusiasts and explore distributed file system knowledge together. Follow me to discover more valuable IT technologies. I'm Hongru from JuiceFS. See you in the next video. Bye-bye.